Composition of functions, sometimes we just call this composite function. Very easy to understand, nothing hard to worry about. So let's introduce another notation. So take a look at this place. We have FOG. So what is FOG? FOG means f of g of x. So the way we read this is f of g of x. So we have x as the independent variable. We have a function g inside a function f. So function g is inside function f. You can put function f inside function g. So the way we write this is we call that g of f. So g of f is g of f of x. Again, g of f of x. We have function f inside function g, and then x is an independent variable. So let's start with a simple example. We have f of x equals to x squared. G of x is a linear function, x minus 1. I would like to find f of g, g of f of f, and g of g. So for the f of g, so we have f of g of x. So let me just put this f o g. So that is f of g of x, which is f of, so g of x is equals to x minus 1, and then function f, it is an x squared, right? So it is an x squared, but now we replace x with x minus 1, so we put x minus 1 inside the parenthesis. And then g of f, so g o f, that is a g of f of x. So this time we put function f inside function g. So function f is a x squared. So g is x minus 1, right? So we replace x with x squared, then you put an x squared over there. And then f of f, so that is f of x. We have function f inside itself. So this is f of x squared. Then we have a x squared inside another x squared. You can call that x to the fourth, but I would like to leave it as like that to make everything easier to read. And then g of g, this is g of x, which is equals to g of x minus 1. So we have an x minus 1 inside another x minus 1. So that will be x minus 1 minus 1. And then what is the domain of these four composite functions? Take a look. So this one we have x minus 1 square, right? So we have a bunch of square, fourth power, x minus 1 minus 1. So basically there is no restriction for x. Do you see that? X can be any numbers. Positive, negative, 0, anything you like. So the domain is x can be any real number. So you write a double bar and then you write an R like that. That is a real number. So x can be any real number. So moving on to more complicated example. Actually, the first one is not that complicated. So the first one, we have a absolute value, and then we have a 2 plus x. So before we start, I would like to say that this function, f of x equals to the absolute value of x minus 3, this function itself is already a composite function because we have a linear function x minus 3 inside an absolute value function. Once again, we have a linear function x minus 3 inside an absolute value function. So this function itself is a composite function. When are you going to use composite function in the future? So you are taking pre-calculus and you will be taking calculus in the future. When you take your first quarter or first semester calculus, you will see this again. They are not going to ask you to find f of g and g of f. So when you see a function in your calculus class at that time, you have to be able to tell that, well, look at this function. I can tell that this is a composite function because this function, whatever it is inside another function. So one function inside another function, you must be able to tell when you get to that lesson in your first semester or first quarter of calculus. So back to our business, we have f of g. So f o g, that is f of g of x. So that is f of g is 2 plus x, right? So this is equals to the absolute value of x minus 3. And then what is x? X is now 2 plus x, right? So 2 plus x minus 3. So we have 2 minus 3, then that is equals to absolute value of x minus 1. So what is the domain? The domain is x can be any real number, right? So you take a number, subtract 1, there is no restriction at all. X can be any real number. And then g of f, this is a g of f of x, which is equals to g of absolute value x minus 3, and then g is 2 plus the x, which is absolute value of x minus 3. This function, x can be any real numbers because you just choose a number minus 3. There is no restriction for that. And then f of f, so this is a f of x, which is equals to the f of x minus 3, and then you have absolute value x minus 3 inside itself, right? So this is supposed to be the x, and then you take that minus 3. So you have to like, the way I showed this in the past is I will just do this. So let's write this all over again. The answer is right. You don't have to erase anything. So for function f, it was x minus 3, right? It was x minus 3. But now you change the x to x minus 3. So therefore, pick up your eraser, erase that, and then replace that with x minus 3. We don't need a parenthesis because that doesn't affect anything. Or you can add that for fun. So this is absolute value x minus 6. Again, the domain is x can be any real number. You know what? Absolute value. Okay, I'm going to fix my mistakes. Absolute value, and then this is absolute value. Absolute value. So if that is an absolute value, then we have to rewrite this. I don't want to break down the absolute value. I will just keep one absolute value inside another absolute value. Like that. So one absolute value inside another absolute value. Okay, just fix my mistake. And then g of g. So this is a g of x, which is equals to g of 2 plus x. So g was 2 plus x, so it is supposed to be 2 plus x, right? Because that is what g is, but you replace x with 2 plus x, so you have to erase this x and then put a 2 plus x. So at the end of the day, you have you either leave it like that, or you can write 4 plus x. The domain is x can be any real number. Okay, so this one is done. Let's move on to the one on the right. That one is a little bit more complicated. So first of all, let's deal with f of g. So we have f of g of x. That is f of g of x. So which is equals to f of x plus 1, right? F of x plus 1, and then you have to change the x to x minus 1. So you have a square there, you have a minus 1. But inside the parenthesis, you have to put an x plus 1. All right. When you do your works online, maybe the book doesn't want you to leave your answer like that, but especially when they are asking for the domain, you have to clean up the denominator, so you have to keep moving. Square the parenthesis, you have x squared plus 2x plus 2, and then you might have a minus 1 over there, right? So therefore, you will have, why do I do a plus 2? 1. And then 1 minus 1 is gone, then you have 2 divided by x squared plus 2x when they are asking for the domain. So this is the composition function. You can leave your answer like that. When they are asking for the domain, this is a rational function. Therefore, denominator cannot be equal to 0. So factor this out, x plus 2, no 0, then x cannot be equals to 0 and negative 2. So x cannot be equals to these two numbers. And then for the domain, you draw a line like that. So this is a negative 2, this is a 0, no negative 2, no 0. X can be anything else. So for the interval, that is negative infinity to negative 2, negative 2 to 0, and 0 to positive 2. So for inequality, this is x less than negative 2, between negative 2 and 0, and x greater than positive 2. 2 to infinity, right? Did I just put 2? That's ridiculous. Infinity. X greater than 0. All right. So that is the f of g. And then the g of f. So we have g of f of x this is a g of 2 divided by x squared minus 1. Then you have 2 divided by x squared minus 1 and then plus 1. So that is your g of f. And then for the domain, you can just say that this denominator cannot be equal to 0. But even though you put them in one fraction, that doesn't change anything. X squared minus 1. So this is a 2 plus common denominator, right? So 1 times x squared minus 1. So even though you do that, that doesn't change anything. That doesn't change the domain. So you have a x squared, 2 minus 1 is 1. And then divided by x squared minus 1. So x squared minus 1 cannot be equal to 0. So x cannot be equal to positive 1 and negative 1. In case you don't know how I got that, I would like to elaborate one more step. X plus 1, x minus 1 factor, right? So x cannot be equal to negative 1 and positive 1. And then you draw a number line like this. So no negative 1, no 1. So not this, not that. X can be anything else. So this will be negative infinity to negative 1, from negative 1 to 1, and then from 1 to positive infinity. For the inequality, the first inequality is x must be less than negative 1, x between negative 1 and 1, and then x greater than 1, if you want to put that in inequality. All right, so let's do the g of g. So let's do the GOG. So this is a g of x. G of x is what? G of x is x plus 1. Then you have an x plus 1 inside the x plus 1. So this one, the domain is all real numbers. X can be any numbers you like. And then the last piece, we have f of f. So this part can be tough. F of x. So f of x is equals to x2 divided by x squared minus 1. Then this part is tough because you will get a complex fraction. So 2 divided by x squared minus 1, right? And then inside the parenthesis, you have 2 divided by x squared minus 1. So that's what makes this part difficult. And then regarding the domain, this is not easy. So this is not easy. You will have to then you will have to do this. Then you will have to clean this up. So you have 2 divided by x squared minus 1 times that. And then this will have a 4. And then this one, after you open that up, you will get you know what? I will just do this. X squared minus 1, I will just do a square, because you will have to minus 1, right? So you will have to take this minus 1, because since for the common denominator, I will just do it right here. X squared minus 1 square, and then 4 minus 1 times that, which is x squared minus 1 square, and then you have a 2 divided by this piece. So 2 divided by this piece, then you have a reciprocal. Then you will have a 2 divided by that, then you will flip this to the top. And then this stays in the denominator. So 4 minus x squared minus 1 square. This, the way you find the domain is you have to fully open up this parenthesis, and then you have to take the 4 minus that. And then I'm not sure if that can be factored. So you have to say the whole thing cannot be equal to 0, and then you solve for x. So that part, I will just leave that piece to you. And then you can take this as the composition function. All right, or you take that as the composition function if they do not accept complex fraction. Okay, so that is the end of this video. If you like the way I explain composition of functions, give me a thumbs up, a share, and a subscribe, and I will meet you all in the next video. Signing out.